Okay, so here is some help with your energy conservation problems. Make sure you know your equations. Kinetic energy is for when you're moving. Gravitational energy is when you are above the ground. And elastic energy is when you are stretched or deformed or compressed. Okay, so with each problem, you need to ask yourself, what kind of energy do they start with and what do they end with? So in this first one, we have a guy at the top of his driveway sliding down into the street. He's going to start with potential energy gravity. He's going to end with kinetic energy. We have to figure out his height above street level, and we do that by saying that his driveway is 15 meters long. The driveway is angled at 5 degrees. So you want to use one of your trig functions to find h. Once you have that height, so that's step one. Once you have that height, plug it into your gravity formula, potential energy gravity, 9.8 for the planet, and the mass of the guy is 75. Once you have that potential energy gravity, use that answer as your kinetic energy and solve for velocity. So that would be step 3, and that's all you have to do. Find the height using trig, use the height to get your potential gravity, set your potential gravity as your kinetic, and solve for velocity. In problem 2, you're going to compress the spring in this car. So you're going to give it elastic energy. Your K value for your spring is given. The compression, the delta X, is given. Make sure you put it in meters. Don't work in centimeters. When you let go of the car, that elastic energy is going to turn into kinetic energy. So whatever you get here, you plug in here, and once again, you solve for velocity. Make sure when you plug in your mass, you work in kilograms, not in grams. Finally, we have one where we're going to use my mask to shoot a super ball as high as possible. So I stretch the mask, and I give the system elastic energy. I then let go, and the ball fires upward to its maximum height. At its maximum height, it's going to have potential energy gravity. Okay, so what I do is I use the mass. Again, I put it into kilograms. 9.8 for the planet's gravitational field. And the height is 4.2 meters. I get my potential energy gravity. I set it equal to the original elastic energy. I do the stretch of 13 centimeters. Again, when I plug it in, I got to work in meters. And I solve for K. I hope this is enough help to get you through, but if not, let me know and I'll work through the problems individually with you.